Pluto, the mysterious bantam planet, dwelling at the external compasses of our nearby planetary group, is working up fervor inside the galactic community. Late reports allude to a potential encounter with Neptune, raising concerns among scientists and space enthusiasts alike. Eminent experts, including Neil deGrasse Tyson and Michio Kaku, have sounded alarms about the possible consequences of this cosmic conflict. But how did Pluto end up on a collision course with its distant neighbor? And how could this potential cosmic crash affect us here on Earth? Let's explore this unfolding event. Once thought to be a full-fledged planet, Pluto was later reclassified as a dwarf planet due to its unique orbit. Despite this change, it continues to charm and attract astronomers. Recent predictions from prominent scientists highlight a worrying proximity between Pluto's path and that of Neptune. These experts warn of a possible impact between the two planets, posing a significant threat to Earth. Pluto's journey around the Sun is marked by its unmatched characteristics within our solar system. Its orbit spans an extensive 248 years, and since its discovery in 1930, Pluto has yet to complete a full revolution. Adding to its intrigue is the highly elliptical shape of its orbit, a departure from the nearly circular orbits of the major planets. Furthermore, Pluto's orbit is inclined at 17 degrees to the ecliptic plane, making its path steeper compared to other planets. One remarkable aspect of Pluto's orbit is its intersection with Neptune's path. For approximately 20 years in each orbit, Pluto ventures closer to the Sun than Neptune, defying expectations based on their respective positions in the solar system. So, why hasn't a collision occurred between Pluto and Neptune? The explanation lies in the gravitational influences exerted by other planets. The study of Pluto's orbit began shortly after its discovery, presenting a puzzling trajectory for astronomers. Unlike most planets, whose orbits align relatively close to the ecliptic plane, Pluto's distinct features include a steep inclination and an elliptical shape. The mystery deepened with the realization that Pluto's orbit crosses that of Neptune. The stability of Pluto's orbit amidst these complexities serves as evidence of the intricacies inherent in celestial mechanics. The three-body problem in space involves understanding the motion and gravitational interactions among three celestial bodies: Pluto, Neptune, and the Sun. This problem explains the intricate interplay of their paths and gravitational poles. Terms like apsidal vibration, scope libration, and the VSK oscillation contribute to unraveling this cosmic puzzle. Astrophysicists assert that the scope libration, responsible for maintaining planets in their orbits, plays a vital role with regard to Pluto and Neptune. This term implies that when Pluto intersects Neptune's orbit, it is positioned at least 90 degrees away from Neptune, crucially preventing potential collisions. Scope libration ensures that when Pluto approaches Neptune or other giant planets, it is situated significantly above their orbital plane, providing an additional layer of safety against impacts. The VSK oscillation explains why Pluto's orbit around the Sun appears unusual, yet remains smooth over time despite apparent irregularity. In the late 1980s, numerical simulations revealed that, despite stable properties, Pluto's orbit is technically chaotic, with minor initial deviations leading to massive differences over thousands of years. However, Pluto's unique orbit maintains stability over incredibly long timescales, keeping chaos in check. Recent computer simulations have enhanced our understanding of how large planets like Neptune, Jupiter, and Saturn influence Pluto's path around the Sun. Neptune's unique relationship with Pluto, completing 3 orbits for every 2 of Pluto, significantly contributes to the stability of Pluto's orbit. Additionally, Jupiter's immense gravity exerts a major influence, while Saturn's effect, though smaller, also plays a role. Through comprehensive tests, scientists have shown that the combined effects of Neptune, Jupiter, and Saturn ensure the safe and stable movement of Pluto in space for billions of years. These phenomena are essential for maintaining the order and consistency of celestial movements in the universe. Without these factors, the solar system would be prone to greater chaos and unpredictability, potentially leading to collisions or ejections from stable paths and causing ripple effects on other celestial bodies. Understanding Pluto's orbit is particularly critical amidst discussions about a potential collision with Neptune in the future. This knowledge provides a clearer understanding of the dynamic nature of the solar system. Pluto's case highlights the fact that seemingly unstable orbits can achieve equilibrium through the complex interplay of gravitational forces and orbital mechanics. Continuous observation and analysis of these phenomena are essential for gaining a better grasp of our place in the universe. Exploring the depths of space often reveals the unpredictable nature of celestial bodies, and Pluto's orbit serves as a prime example of this unpredictability. The concept of orbital chaos vividly illustrates the delicate dependence of a celestial body's path on its initial conditions. As demonstrated in Pluto's case, even slight variations in the dwarf planet's position or velocity can significantly alter its long-term orbit. Virtual simulations have been instrumental in helping scientists understand how Pluto moves through space. By making small adjustments in these simulations, astronomers can observe how minor changes can have a profound impact on Pluto's trajectory. In the late 1980s, these simulations revealed an interesting aspect of Pluto's path. Despite factors like apsidal motion and scope libration contributing to its stability, Pluto's orbit can still exhibit unpredictability. Even a tiny initial difference in Pluto's position or speed can lead to significant changes in its path over many years. Regardless of this inherent chaos, Pluto's orbit remains stable for an extraordinarily long time, extending over billions of years. This suggests that beneath its seemingly erratic appearance, Pluto's journey around the Sun follows an organized order. Predicting cosmic events, especially those involving planets like Pluto with erratic orbits, is extremely challenging. The inherent unpredictability of these systems makes long-term forecasts uncertain. Numerical simulations help us understand and anticipate the future paths of celestial bodies, but they also reveal the limitations of our predictive abilities. These models rely heavily on precise initial conditions and simulate complex interactions. Even a small error can lead to significantly different outcomes, making accurate predictions difficult. The chaotic nature of celestial orbits, such as Pluto's, reminds us of the ever-changing universe. While we've made progress in understanding space, Pluto's case highlights our still limited knowledge. Understanding the gravitational effects of giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It demonstrates how each planet's presence and position can influence the stability and trajectory of other bodies in the system. Despite these intricate forces, prominent astrophysicists are expressing concerns about a potential collision between Pluto and Neptune. This raises questions about why such a collision, which seems unlikely given these complex dynamics, is now a subject of concern. Neil deGrasse Tyson, a renowned astrophysicist, presents a unique perspective on the mysteries of our solar system, particularly regarding Pluto. Tyson, famous for reclassifying Pluto as a dwarf planet rather than a full-fledged planet, shares sharp insights into how our understanding of celestial mechanics is constantly evolving. Tyson sees Pluto's reclassification not as a demotion, but as a necessary adjustment to our growing knowledge about the diverse objects orbiting the Sun. His approach to celestial mechanics involves continuous learning and adaptation. He views the complexities of orbits like Pluto's as a reminder of how much more there is to discover in space. Tyson believes the charm of these mysteries makes cosmology so captivating. Moreover, he is aware of how space-related events and discoveries shape public interest in astronomy. He thinks occurrences like Pluto's reclassification and its unusual orbit are opportunities to capture the public's imagination and curiosity about the universe. By discussing the dynamic and sometimes counterintuitive aspects of space mechanics, Tyson aims to foster a deeper understanding and appreciation of the cosmos. He works alongside other scientists to actively warn the public about the potential danger of Pluto's unpredictable path. After extensive study of Pluto, Tyson has raised concerns that the three-body problem could pose a genuine threat, suggesting that a collision with Neptune is long overdue. Furthermore, Tyson emphasizes how such a collision could disrupt the balance of the universe and lead to catastrophic consequences extending to Earth. A collision between Pluto and Neptune would be an extraordinary and devastating event in our solar system. This impact would release a massive amount of energy, likely shattering Pluto due to its smaller size and icy composition. Debris from the collision could spread across the solar system, posing potential hazards to other planets and their moons. For Neptune, such an impact could potentially alter its atmosphere and orbit, depending on the specifics of the collision. Michio Kaku, a renowned theoretical physicist recognized for his work in string theory and science advocacy, offers an intriguing perspective on this scenario.